It's almost time for the SAT. So here are the top 5 kinds of problems that you're going to need to know how to do. And the last problem in this video is going to be the most important kind of problem on the SAT. So here's the first problem that we'll be going over in this video. For this one, we just need to solve for x in this equation. So how are we going to solve this problem? Well, remember that solving for x means that we need to get x by itself. And to get x by itself, we need to do things to both sides of the equation. So we could get rid of this 2 first that's next to x, but I would rather get rid of the 5 first because it's less attached to the x. If we were to get rid of this 2 first, we would be dealing with fractions and stuff. So here we have a minus sign next to 5. So to get rid of the 5, we need to do the opposite of minus, which is plus. So we will add 5. But remember that whatever you do to one side, you have to do to the other. So we're going to add 5 to the other side. So minus 5 and plus 5, those cancel out. And on the left side, we're just left with 2x. And on the other side, we have 3 plus 5, which is 8. And now we can get rid of the 2 that's next to x. But you might be wondering what the opposite of this is, because there's no sign at all. Well, remember that when there's no sign in between a number and a letter, that means it's multiplication. And the opposite of multiplication is division. So we'll divide both sides by 2. These cancel out, and on this side we'll just have x equals 8 divided by 2, which is 4. So our final answer is x is equal to 4. So yeah, make sure that you know how to solve for x before moving on because it's something that you're going to need to do for all kinds of other problems. So here's the second problem that we'll be doing in this video, and for this one we need to write the equation of this line. So for this we need to remember that the format for a straight line is always y equals mx plus b. Now x and y are probably the most familiar to you for a graph. Y is the up and down value. So however much you're going up is its Y value. Or if you're going down, that means Y is becoming negative. And then X is the same thing, but for left and right. So as you go to the right, X goes up. And as you go to the left, X goes down. It becomes a negative. Now what about M? Well, M is our slope, or the slope, some might say. And then B is our y-intercept. So what is slope? Well, remember that slope is just the steepness of a graph. So the steeper the graph gets, the higher the slope. So something like this would be very steep and have a high slope. So to find the slope of this graph, we need to use the slope formula, or the simpler version of it, which is rise over run. So to find rise and run, we need to pick 2 points on this graph and figure out how much it rises and how much it runs. So I like to pick points that are nice and even and aren't going to give us fractions. So for example, this one right here, it's right in the corner of these boxes. It's not going to have decimals or fractions or anything, so that's a good point to pick. And then this one is also a good point to pick, right? It's in the corner of these boxes. So first, how much do we need to rise? How much does the graph need to go up to get from this point to this point? Well, to get up from this point to the level of this point, we need to go up 1 box. And see, now we're on the level of this point, which means our rise is going to be 1. And now what about our run? Run is how much we need to go to the right to get to this point. Well, we're starting here, right? We need to go 1, 2 boxes this way. So the run is going to be 2. And remember that slope is rise over run, or rise divided by run. So rise is 1 and run is 2. Our slope is 1 over 2. Now, what about our boo y-intercept? Well, our y-intercept is basically wherever it crosses the y-axis. The y-axis is this line right here that has a y next to it, the up and down line. So it's how far up or down we need to go. So this is the middle of our graph. This right here is 0. And to get to where the graph crosses the line, we need to go down 1 box. Remember that when we go down, that means that's negative numbers. If we were going up, it would be positive. So because we went down a box, our y-intercept is -1. So now all we have to do is rewrite y equals mx plus b, but instead of m, we're going to put what we found for our slope, which is 1/2. And instead of b, we're going to put what we found for our y-intercept, which is -1. So y and x are going to stay the same. So we're going to have y equals m, which we just found out is 1/2. So 1/2 x. Or whenever you have 1 over something in front of x, another way you can write it is x over 2. This is important to know if you're doing like a multiple choice question and you're like, none of them say 1 over half x, but if it says x over 2, that means the same thing. And then we have plus b. So b is -1, so we have plus -1. But having a plus and then a minus is kind of useless. So instead, we can just write -1. that means the same thing. So there we go. We've now written the equation that represents this line. So here's the third problem that we'll be doing in this video, and it's pretty similar to the last one we just did, except instead of writing the equation with a graph, we need to write it with a table. So I guess one way that you could do this is just to draw a graph and then plot these points on it and then try to figure out the equation. But honestly, drawing a graph takes too much time and it's probably going to be inaccurate. So instead, we can just use the same equation of y equals mx plus b, but without having to graph stuff. So remember that m is our slope, but how do we find the slope if we can't see the line? Remember that y is up and down and x is left and right. So the slope is just how much y changes when x goes up by 1. And we can see that from this point in the table to this point, x goes up 1. So all we have to do is figure out how much y changes, and that's going to give us our slope. So from here to here, how much does y change? Well, it looks like it was at 8, and now it's gone down to 5. So it's gone down 3. So when we increase x by 1, y is decreasing by 3, which means our slope is -3. So see, we were able to figure out what our slope would be if we graphed this, but you don't actually have to draw a graph to understand it. So now what about b? Well, remember that b is our y-intercept, and the y-intercept is basically wherever the graph crosses the y-axis. So if we had a line like this, then our y-intercept would be right here. So how do we figure that out without a graph? Well, when the graph crosses the y-axis, what do you think x is? Remember that x is left and right. So whenever the graph crosses the y-axis, x is 0, because x means left and right, and it's not going left or right at all. It's staying right in the middle. So to find our y-intercept, all we have to do is figure out what y is, how up or down it is, when x is 0. And we can see that x is 0 right here. So whatever y is our y-intercept. In this case, that's 8. So our y-intercept is positive 8. So now all we have to do is rewrite y equals mx plus b, but with our slope and y-intercept, just like before. So we're going to have y equals, and then instead of m, we're going to have -3 x plus 8 instead of b for our y-intercept. And this is our final equation of the table. All right, now here's a problem that's a little bit more tough. Before, in the first problem we did, we had to solve for x when we had one equation. But in this case, we have two equations and two unknowns. Now, there's two main ways that we can solve systems of equations. The first way is by substitution, which basically means we need to take one of these equations and solve for a letter. Now, you could do that for this, and actually solving for y would be pretty easy because y is already by itself here, and all you have to do is subtract the 3x or the 4x. So that's a totally normal way that you can do it. But a lot of the times in the SAT, they'll purposely set up problems so that there's a little shortcut that you can do to solve the problem. And the only way to get this shortcut for this problem is actually by doing the second method of solving systems of equations, which is elimination. And basically with elimination, we want to add the two equations together to eliminate a variable. Now, if we were to add these equations together right now, we wouldn't eliminate everything, right? We'd have 4 plus 3, which is 7, and then y plus y, which is 2y. We're not eliminating anything. But with elimination, we can also subtract equations from each other. And in that case, that would mean changing the signs of the bottom equation. So we're turning these into minuses. And if we subtract these two equations, then you'll notice that something crazy happens. So we have 4x minus 3x. 4 minus 3 is 1, so there's just 1x. And then plus y minus y, well, those do the opposite, so those cancel out. And then 7 minus 2 is 5. And you'll see that suddenly we've magically solved for x. X is equal to 5. So if you had done this with substitution, that would have been totally fine. It just would have taken longer. And on the SAT, time is everything. So spending more time on the problem means less time you can spend on other problems. Now, I said at the beginning of this video that the final problem was going to be the most important skill. So possibly the most important skill that you'll need on the SAT is being able to take a real life situation and write an equation out of it. So for these problems, we just need to take it slow and think about it logically. So let's go ahead and look at this problem. A restaurant sells burgers for $5 each and fries for $3 each. A guest bought 10 food items for $42. How many burgers did he buy? So let's just look at that first sentence. Don't worry about the second sentence for now. Let's look at the first sentence and write an equation out of this. So we know the price of the burgers, right? The price of a burger is $5. But we don't know how many burgers he bought. That's actually what we're trying to find. So I'm going to use a letter for this because a letter means we don't know what the number is. And the number and the letter are actually going to be multiplied together. I'm using B for burgers, by the way. These are going to be multiplied. And remember, when there's no sign, that means multiplication. These are multiplied because we have to multiply our price by how many burgers we're buying to get the total price. And if you weren't sure of that, just think about how it would be if you bought a burger in real life. If a burger was $5 in real life and you bought 3 of them, then how much would you have paid for the burgers? Well, you'd probably say, I paid $15 for the burgers. And the way you figure that out was because 5 times 3 is 15. So now we need to take into account that fries are $3. Well, the price of the fries is added on to the price of the burgers. So we're going to put a plus sign here. And how much you pay for fries, you'd find the same way as burgers, except this time we're multiplying 3, which is the price of the fries, by however many fries we're buying, which in this case is F because we don't know how many. Now that's the first sentence done. This is the final cost, so however much we pay in total at the end is going to be 5b plus 3f. But you'll notice that this isn't an equation. We don't have an equal sign, so this is kind of useless on its own. But from the second sentence, we do know that it says that a customer paid $42. So this is our final price, and we know that the final price for this specific customer was $42. So we can say that this is equal to 42. So let's say that you knew how many burgers and fries they bought. This customer is basically saying, oh, I bought however many burgers and I bought however many fries. They plug those into this equation and they ended up getting 42. Now, can we just go ahead and solve for B now because we're trying to figure out how many burgers that they bought? Well, no, because we have 2 letters here. You can't solve for 2 different letters if we only have 1 equation. But as we saw in the last problem, we can actually solve an equation with 2 letters if we have 2 equations. So what other equation can we write using the information that we have? Well, the problem says that they bought 10 food items. So they could have bought like 3 burgers and 7 fries. They could have bought 10 burgers and no fries. They bought a total of 10 items though. So how would you write that as an equation? Well, let's think about this logically, right? We would count all of our burgers, right? However many burgers we have, and we'd add it to however many fries we have. And once we add together how many food items we have, we know that the total is going to be 10 food items. So for example, if you know that they bought 3 burgers and they bought 7 fries, that would be 3 plus 7, which is 10. So how are we going to solve for, well, what are we actually solving for? Well, remember that the equation is asking for you to figure out how many burgers they bought. So we only have to worry about solving for B, although we could solve for F as well. So we could do either substitution or elimination in this case. Elimination would get a little bit complicated because we'd have to multiply things because this isn't going to cancel out very easily. So let's go ahead and use substitution, and actually let's do substitution on this second equation. You can do it on either equation, but the second equation, the letters are already mostly by themselves, right? So it's going to make our lives easier this way. Now here's the important thing. We want to solve for B, but because we're doing substitution, the first equation, when we solve for a letter, we need to solve for the other letter. So because we want to eventually figure out what B is, I'm going to get F by itself. And you'll see why I'm doing that in a second. So let's go ahead and try to get F by itself. The only thing that's on the same side as F is B. So let's get rid of the B by subtracting it from the equation. So B minus B, that just turns into 0. So these cancel out. And all we're left with here is F. And on the other side, we have 10 minus B. Well, you can't subtract a number and a letter, so it's just going to stay as 10 minus B. So now what we're going to do is we're going to bring back this first equation. But instead of F, we're going to write what we just found out F is, which is 10 minus B. So instead of 3F, we now have 3 times 10 minus B. And then that equals 42. So that's the reason that we solved for F instead of B. We were trying to find B, but we solved for F because eventually we're trying to get rid of F in the other equation. And now all we have left in this equation is the letter B, which means we can solve for B. And remember that B is the amount of burgers that this person bought. So if we solve for B, that'll give us our answer. So let's go ahead and solve for B. I'm noticing that here we have a number in front of parentheses with a lot of stuff in it. And whenever you see that, that should say in your head, this is the distributive property. And if you remember what the distributive property is, that means that whenever we're multiplying a number by things in parentheses, we have to multiply the number to all the parts in the parentheses. So this 5b is just going to stay the same. We're not doing anything with that yet. And then we have 3 times 10 and 3 times minus b. So 3 times 10, well, that's 30. And then 3 times b, but this minus sign actually has to stay. So this is going to be 3 times minus b. You can't multiply a number and a letter, that you can't do 3 times b. So it's just going to stay as 3 times b. And we do have a minus sign here, so the minus sign has to stay. And then this is equal to 42. So now the last thing we need to do is to get b by itself. It would be like if we were getting x by itself, but the letter itself doesn't matter. But this might be kind of complicated because we have two b's here. So how are we going to get b by itself if there are two of them? Well, let's go ahead and solve that problem by combining these two things. Remember that when you have two terms with the same letter, then you can combine them. It's creatively called combining like terms. So we have 5b's, and then here we're subtracting 3 of them. So 5 minus 3, we only have 2 left. So that's going to be 2b. So these two terms, these two parts, are combining into 2b. So we have 2b plus 30, and then that's equal to 42. And now the letter b only appears once, so we can solve for it by getting it by itself. So like I talked about before, the 2 is more attached to the b, so I'm going to get rid of the 30 first. And we have a plus here, so we can get rid of it by doing the opposite of plus, which is minus. So we'll subtract 30 from both sides. These cancel out, and on the left side we just have 2b equals 42 minus 30, which is 12. And now all we have left is multiplication because we don't have a sign. The opposite of multiplication is division, so we're going to divide 2 from both sides. The 2's cancel, and we just have b on this side equals 12 divided by 2, which is 6. So b is equal to 6. So this is our final answer. Our guest at this restaurant has bought 6 burgers. So yeah, those were 5 of some of the most important topics that you'll need to know for the SAT math section. So the advice that I can give to you is to practice for the SAT. Keep doing more practice problems like that. But even though those are some of the most important topics you'll need to know, those aren't the only topics. So if you're looking to get even more SAT practice, then you can watch this video right here, where I go over some other topics that you'll need to know, including some geometry stuff. And as always, if you have any questions about any of the stuff I went over in this video, go ahead and leave a comment, and I'll be sure to answer your question. Thanks for watching, and good luck on the SAT.